So this problem is asking about the reaction between nitrogen gas and hydrogen gas to produce ammonia. Anytime that we want to solve stoichiometry problems, we need to start with a balanced chemical equation. So first, let's react nitrogen gas with hydrogen gas. Remember that nitrogen and hydrogen are both one of your diatomic 7, so in their elemental states, they exist as diatomic molecules. So nitrogen gas reacts with hydrogen gas to produce ammonia gas. We're working with the right reactants and the right products, but it needs to be a balanced chemical equation. So in order to make this a balanced chemical equation, I need to place a 2 out in front of my NH3 and a 3 out in front of my H2. Now this is a correctly balanced chemical equation. Now I can identify mole ratios so that I can solve problems like these here. So the first problem is asking if 2.40 moles of hydrogen react with nitrogen, how many moles of ammonia will be produced? Okay. So I want to know how many moles of ammonia I can produce from 2.40 moles of hydrogen. So I need to establish some sort of relationship between my hydrogen and my ammonia. Well, if I look at my balanced chemical equation, I can see that for every 3 moles of hydrogen that react, that's going to produce 2 moles of ammonia. Let's transfer this color coding down here. And let's write off to the side up here my relationship between my hydrogen and my ammonia. For every 3 moles of hydrogen that react, that's going to produce 2 moles of ammonia. So now I can use this as a conversion factor. So for every 3 moles of hydrogen, that's going to produce 2 moles of ammonia. We can see that our moles of hydrogen as a whole unit with my label cancel. Leaving me with moles of ammonia, which is what I wanted. So 2.4 times 2 divided by 3 gives me 1.6. moles of NH3. At this point, you might be thinking about significant figures. Okay. We are doing a multiplication and division problem. So our answer should be rounded to have the same number of significant figures as the measurement that has the fewest number of sig figs. So this measurement here has 3 significant figures. My mole ratio, these are counted numbers. My mole ratios will always have an infinite number of significant figures. So my answer should have 3 significant figures. My calculator gave me exactly 1.6, so the rest of those digits are zeros. So my final answer here is 1.60 moles of ammonia. For the second question, if 1.6 moles of nitrogen reacts with hydrogen, how many moles of ammonia will be produced? Well, I want to know how many moles of ammonia will be produced if I react 1.60 moles of nitrogen. So let's establish a relationship between my nitrogen and my ammonia. My balanced chemical equation tells me that for every 1 mole of nitrogen that reacts, that's going to produce 2 moles of ammonia. So let's write that as an equivalence over here. So now I can use this as a conversion factor to convert between moles of nitrogen and moles of ammonia. I want my moles of nitrogen to cancel out. Okay. So for every 1 mole of nitrogen that reacts, that's going to produce 2 moles of ammonia. So 1.60 times 2 divided by 1 gives me 3.2, and I need 3 sig figs, and so that third digit is assumed to be 0. 3.20 moles of ammonia. Now it's always good to go back and check your work to see if they make sense. My reaction is telling me that for every 1 mole of nitrogen that reacts, that's going to produce 2 moles of ammonia. Well, in this particular problem, I have a little bit more than 1 mole of nitrogen, so it would make sense that I would make a little bit more ammonia than what my recipe tells me. The same is true for my hydrogen. Okay. So my recipe is telling me that for every 3 moles of hydrogen that reacts, that's going to produce 2 moles of ammonia. I didn't quite have 3 moles of hydrogen here. I had a little bit less. So it would make sense that I would make a little bit less than 2 moles of ammonia, which is what we found. So always go back and check to make sure that your answers make sense with what your recipe is telling you.